Heh. Stream looks good. Make this a little bigger. Stream looks good. Make this a little bigger. Stream looks good. Make this a little bigger. Little bigger. Alright, I just want to check if the stream's good. Just a little bigger. Alright, I just want to check if the stream's good. Well, that looks good. Why is it? Alright, I just want to check if the stream's good. Well, that looks good. Why is it? Oh, that's why. It was picking up audio. Okay. It's picking up desktop audio. But it was picking up audio. Okay. Alright, stream looks good. Alright, let's do some studying, guys. I'm gonna write a paper, and then I don't know. I'm half naked. We're making top G content every day, so. Alright, let's see. Oh, I wish I could see comments. Actually, can I see comments? How do I add comments to it? Studio mode. No. Controls. No, what the heck? Docs. No, I don't want doc. Oh, that was loud. Chat. This is YouTube chat. Let's go. Okay. I think I got everything down now. All right. We're going to write this paper about this. Let's see. Determination of water content. Make my camera a little bigger. Determination water content lab. It's our first lab. What we did was we went to a part of the woods on our campus at Emporia State University, and we just got the like soil of it. It's kind of weird. Oh, you can hear me drinking water, but it's fine. So I'm just writing a lab report. So, and then we also have to write this soil sample thing, where like you can see it or not. And I have two sheets. One is for the draft, one is for the actual, so it's nice. Alright, so let's see. The purpose of the lab was to find moisture content from soil samples collected from Emporia State University campus woods north of the tunnel entrance. North of the tunnel entrance, mind you. The collection of the samples, named CW22, had to be quick as moisture content would have been lost. The first objective was to find an area to have a dig site. A dig at? Oh, what the heck? Doug site. How about that? One of the factors of choosing a digit. What's a digit? Is that an actual word? Is that an actual word? Digit? What's digit? A digit's a snake. Okay. Look at this. A digit is a snake, guys. All right. For some reason, it went from Doug site to digit. That's weird. All right. So let's see. Dig. I don't know why it says digit. Doug site. It's a good thing I'm rereading again. One of the factors of choosing a Doug site was trees. Roots of the tree can cause issues when digging a hole. After finding a good site, alright, I should because because organic because we because the samples need to have less organic material. Alright. The roots of the trees. I don't think it causes trees. Doesn't sound right. Roots of the tree can cause issues when digging a hole because the samples need to have less organic material. I don't think it causes it. Alright, let's rewrite that. Roots of the tree can give more organic material. Can give more unnecessary. Can give more organic. Let's just stick with that material. Roots of the tree can give more organic material, which well, the reason we don't want roots of the tree is because we want the topsoil. We want the soil to not have as much. I'm trying to word that out. So roots of the tree can give more organic material. Give more into how about into the soil samples. The soil samples. Roots of the tree can give more organic material into the soil samples. Tree can give is not the right word. Roots of the tree can give more organic material into the soil samples. Unneeded, maybe. Can give. I don't like the word give in this sentence. Roots of the tree, it doesn't make sense. Roots of the tree can cause more unneeded. Can have more unneeded. Roots of the tree can have more unneeded. Can have unneeded organic material. All right. How about provides unneeded? How about it? Roots of tree provides unneeded organic material into the soil samples. Okay, I think that's better. After finding a good dig site, a good site to dig, a rectangular surface was drawn out with shovels and then removed. Okay, that's not bad. The length of the dug site was around 2 to 6 feet. The reason to remove the surface area is to have less organic material mixed with the collection of samples. Once the surface horizon was moved, about 1 or 2 feet was digged down for the collection. Digging down a couple feet gives samples with higher clay content percentage, which in turn has more moisture content because clay can hold water. The samples were collected in 5-gallon plastic bags. Okay, that makes sense. The color of the soil under sunlight, seen under sunlight, was a dark brown to dark gray. Using a Munso color book, a more accurate color would be 5YR14 under sunlight. After they're collecting samples, they're placed in a dark cabinet for a couple of days. I think we should just leave it at that. Alright. The next part is to transfer the soil samples to tin cans so they can be weighed. There are two sets of data needed: mass of the soil of a wet soil mass of we're taking multiple, so it wouldn't make sense for me to say a wet soil mass of wet soil samples. Let's add an S to that, and dry soil samples. All right, to start data collection, any remaining organic material from the samples need to be removed quickly to avoid adding unnecessary mass. Let me read that again. To start data collection, any remaining organic material from the samples need to be removed quickly to avoid adding unnecessary mass. Okay, I should probably, and the reason we have to move them quickly as well is because the, what's it called? The organic materials such as like small parts of roots, grass and whatnot, or like worms, they all hold water, and so we had to take it out quickly as possible so we don't lose as much water content uh, for the soil. So I probably should add that part as well. So any remaining organic material from samples need to be moved quickly to avoid adding unnecessary mass. And let's not do that. Let's start a new sentence. Organic material needs to be removed quickly. Let's add maybe a semicolon. Is this one? Yes, I got a semicolon. And also, okay, have this removing the organic material. Removing. All right, hold up. Any organic samples to be removed quickly to avoid unnecessary mass. Okay, let's just quickly. Also prevents moisture loss. I think that makes removing the organic material quickly also prevents moisture loss. I think that makes sense. That's cool. Let's see. Okay. All right, where were we? And then let's see. Mass. Removing organic material quickly also prevents moisture loss. Afterwards, the soil samples will be mixed, then quartered. The next step, afterwards, the soil samples will be mixed, then quartered. The next step is weighing the mass of the tin cans. Then, this should be afterwards. Okay. All right, let's see. Afterwards, soil samples will be mixed, then quartered. And I should probably add, this was done, mixing and quartering was done, and quartering of the soil. What am I typing? Of the soil was done 3 times, I think. 3 times. I'm gonna say 3 times. I know we did it at least 2 times. 3 times. Okay. The next step is weighing the mass of the tin cans, including its lid. All measurements were measured to the 100th decimal and in grams. Transfer the soil into the tin cans and weigh the total mass. Let's transfer the soil into the tin cans and weigh the total mass of total mass of both the tin cans and the soil. Alright. Okay. Transfer the soil into tin cans and weigh total mass of the tin cans and the soil. Alright. The samples are considered as the wet sample. Place the tin cans into an oven at a constant temperature of 110 Fahrenheit. After a day or so, after a day, measure the mass of the cans again. The expectation is that mass is less due to the loss of moisture being in the oven. Being in an oven. This is the dry sample. This one I don't think we include. This is the total, right? Yeah. Okay. This is the dry sample. It's kind of a short sentence, so maybe we could do a comma splice, or not comma splice, but semicolon. Okay. The expectation is the mass is less due to the loss of moisture being in the oven. This is the dry sample. Okay. What else do we need? What else did we did? Okay. Then I think that's it. Alright, I'm reading the there's a study guide for this. Water. There's not much that we did for this, if I'm being honest. Yeah, it's a very short lab. Okay. I guess I can talk about my data now. Okay. Alright, if we're gonna talk about data, I have to make an Excel sheet. Alright. Excel! My favorite tool. What the heck? Alright, let's make an Excel sheet. I'm trying to get the camera here. Alright, so an Excel sheet, so let's see. Can number. This one is mass of can. Oops. Mass of can. And then mass of can. Oops, come on. Excel weird. Plus soil. Plus soil. Mass of can plus dry soil. The first one's wet soil, but I think as long as one of them's different, it's fine. Mass of moisture loss, mass of moisture. Okay, I spelled moisture wrong. I just spelled water because I don't know how to spell moisture. Mass of dry soil. Gonna be in the water content. Average. And then we'll do average. Okay. So can number 1, 2, 3. Mass of the can. First one is 20.75. Next one is 20.91. Next one is 20.73. Coughing. I'm making top G content. I look like Andrew Tate right now. Yeah. Mass of the can plus soil. This will be this plus 50.12 because I did not put the total down for the mass of can plus soil, so I have to put it point, what is it, 5.3. I'm gonna put 5.3. K, and then I hope that's 5.3. And then this one, oops, plus, let's see, 50.73. Cool. Okay. Now the wet soil or the dry soil. This one I don't need to do math on. Luckily, 60.61 because we measured it. All right, I put 61.60 K, and then 62 even. Then this one is 61.65. Mass of the water, which is M2 minus M3. Okay, so it's this one minus that one, which should be, that seems about right. Mass of the dry soil, which is M3 minus N1. So this one, wait, what? Oh, it's M1. So let's see. Mass of the can's M1. Okay, so M3. So it'll be this one minus this one. Be 40.87. That's not bad. Then water content. This one's a little more complicated, but it's fine. So it will be M2 minus M3. So M2 minus M3. What's M2? So M2, is that the M2 wet soil? So M2 is the wet soil minus the dry soil divided by, I think, M3, which is the, let's see, which was one, is the dry soil. Let's see. I think it's the dry soil. Yeah, it's a dry soil. Good thing I labeled. Oh, wait, let me do this parentheses. So M3 minus M1, which is just the mass of the can, I think. Okay. 2.2, that seems about right. Apply the same one. Average is, let's see. Oh, shoot, I forgot. Oh, no. I also need to times this by 100. There, that makes way more sense actually. Yeah, that makes more sense. And then the average is this two. Okay. Actually, let me type in average. That should be it, I think. Yep, that looks about right. 23%. Let's make this cleaner. Let's make this cleaner, because since our decimal points are no more than the tens value, they're hundreds of a decimal. Alright, that's the easy part, which isn't so bad. Alright, so that I did that. I write that on a piece of paper, it's fine. Alright, let's make this more neat. Let's make this more ES1. So this one is called ES. And this one's called ES2. This one's called ES3 for Earth Science, obviously. Why is this not capitalized? Why is this not capitalized? Okay. Can number. And then I think I got everything actually. Let's just let's move this here. Let's move this here. Mass of water, mass of soil plus of wet soil. Okay. content. So our average water content is 22.21 or 23.21%. And then this is gonna be our table that we're gonna add to our let's make a table. Let's make this a little bit bolder. Oh wait. Yeah, that seems to work. Huh. Let's make a. How do I delete this? Let's see. How do I white out? Hold on, I'm gonna look this up. How do I white out? How to white out Excel sheet. Page loadout. Oh, that's how you do it. Okay. Background. No. Where did I? Oh. Oh, I spelled item wrong. I want to delete this part. Let's see. Come on. There you go. Excel grid lines. Yeah. That's how to hide grid lines. Let's see if this guy has anything.
Day.com to boost your team's efficiency.
So 1 minute video. So maybe we got something.
Welcome. In this short tutorial, you'll see the easiest way how
This
to
person's
hide
already
grid
knowing.
lines in Excel, either in the whole spreadsheet or in a selected area. Ready to start?
Yes.
Hello and welcome to EasyClick Academy. My name's Maria.
Oh my
Make
god,
sure
how
you'll
do
be
you make a
able to
1
use
minute video
Excel in a
long?
quick and easy way. Simply click on View tab, go to the section Show, and unselect the option Grid Lines. The grid lines immediately disappear from the whole spreadsheet.
Oh, that's easy. Alright, can I do it specific? Oh, I'm gonna do it specifically. View grid lines. Whoa, that's just annoying, isn't it? Oh, wrong one.
And the area looks nice and clean. In case you need the grid lines to be visible in the sheet, you can simply select the option Grid Lines and they'll be back on, making it easy
Well, how
to
do I-
navigate through the cells.
How do I...
Now, you might wonder, what if I need to remove grid lines only in a selected area?
Yeah, that's what I want. That's what I want. Yeah.
This little tip will do the trick. Let's say we don't want grid lines to appear in the data table.
Yeah.
We select the area of the table, go to Home tab, and use the function Fill Color to change the background color of the area to white.
Oh.
Thanks to this, no grid lines are now visible.
Whoa, that's just plain easy, isn't it? Okay, home. Fill. Yeah, that's so much easier. Wow. Alright, I want this as well. But this partner. Right. And then this. Actually, let's white out this. Let's white out that. Let's remove. How do I remove? I want to remove this. I guess I just remove the entire thing then. No border. Okay. And then we'll do a thick one on the that's a little problematic, isn't it? Let's move this down a little bit. I want to remove this. Okay, how about this? Why is there no more borders? Let's see. Did I do it? I did. Let's go. Okay. So this should be test num. Okay. Okay. Actually, let me highlight this. This one should be average water content. Percent. So, okay, what else do we need? There wasn't much to this one, I think. I don't know if I could. If I'm being honest, I don't know what else I could put on here. Alright, let's put in test results. Highlight that. And then main. I mean, that looks pretty good in my opinion. Table 1. What should I write for the heading? Can of I always have trouble writing the heading for these things. Okay. Let's see. What should I write for the figure heading or table heading? So this is about the mass of can. Most soils that are sandy, gravel nature might have water content too. Okay. Is it still in boldface? The temperature for the oven was had a plus, or how do I add an equation? Insert equation. Oh no, equation. Let's see. Plus minus 110 Fahrenheit, right? Oh, it's Celsius? Oh, wow. Then there's a degree symbol. Yeah, there is. Had was around. When the samples were put in the oven. Okay. Then I won't do that. That's boldface. Someone texted me. Who texted me? Oh, she's so weird. That's a cute baby. Alright. This is gonna be weird. Third person. Imagine live streaming your homework. Let's see. Let's eat. Oh. Alright. The oven, the temperature of the oven was around 110. We'll put in the oven. I don't need to put in, or need to say it. I put in the oven twice. Alright, what else can I put in for that? Because there's nothing else left for the paper. This like cooling the dry soy after drying. I don't have a desiccator. So all the lab report needs is a cover page, equipment used, description of test procedure, results, data sheet, and sample calculations, sources of error. Okay. Oh, I should probably add more description towards soil. All right. Because it wasn't a silty clay. I don't know what silty clay is actually. Let me look up silty clay. Silty clay. Oh, is this silt? What is silt? Let's look up types of clay. Types of clay. Of clay content. Let's see. Soil textures. Okay. Soil texture. Oh, no. Wasn't that much silt in it, though. Okay, I guess it's a very loamy clay. clay loam, silty clay, silt loam. Okay, alright. One of the factors of choosing duck site, I have to find good duck site. Where is it? Where is it? I should probably talk about texture. Can be a loamy. Alright, I gotta look up what loamy is. Loam, silty clay. Loam, silty clay. I need to look at images. Can be described as a loam, silty clay with let's actually with a high clay content percentage. Okay. I think although it was not part of the lab, the clay was stable enough to hold. Although it was not part of the lab, the clay was stable enough. The clay, let's not mention that. The clay the soil had enough clay to hold itself to make ribbons. Let's just say to make ribbons or imprint easily that that word long, that held on. Alright. Temperature. What else can I results? Data sheet and sample calculations. Okay. Oh, I should probably mention to find the what did I have to calculate actually? I think I had to calculate mass of the moisture. Of the moisture used calculation. Let's actually insert calculation, and then let's see. This one will be let's see. Mass of mass of can plus wet soil minus plus mass. Put that in parentheses. Minus mass of can plus dry soil. Let's actually bring that up. That one's pretty easy. To find of dry soil, use the sample calculation. We use the sample calculation. No. Let's see. Mass of can plus dry soil minus mass of can. Why is this in the middle? There we go. That's actually cool. To find water content percentage, use the sample calculation. Use a simple calculation. Okay, this one's gonna be Uzi, but it's fine. Let's do a fraction. This one might be a little hard. Okay, this one is M2, so mass of can plus wet soil. Mass of can plus wet soil minus mass of can plus dry soil. Okay, so that looks good. Mass of can plus wet soil minus mass of can plus dry soil over M3, which is mass of can plus dry soil minus mass of can times this by 100. Alright, that looks good. And then take the 3. Alright, I think that looks pretty good in my opinion. In case people don't know what average is, the average content percent. And dividing by 3. Let's do is found by number of data sets. I think I'm almost done. Sources of error. Okay. Do we have an expected value? Actually, error, boldface. Technically, I've only written like. That's crazy. I've only written like. Hey, hey, hey. Sources of error. Alright. The number one, a source of error can be moisture loss. The second, the second the soil was dug out of the ground. The ground, what else could have happened the second it was dug out? The ground, another time. Another moment. Where moisture loss could happen is mixing, is cleaning, is taking out organic material and mixing the soil. Another moment when another moment moisture loss could have happened is when the organic matter and material was being cleaned out and the soil was being mixed. Moving the soil. Moving the soil could have caused heat. Increase causing more evaporation of water. Source of error can be moisture loss. Another source of error. another source a potential source of error could be the tin cans. Experiment are new. Although the cans for the experiment are new, a rusted can change the mass. Conclusion. In conclusion, what is it, 23.21% is 23.21%. What else should I write? It's not much I can say about it, if I'm being honest. Conclusion. Water can't be found in 3.21%. Percentage which in turn holds more water. Oh man, this is tiring. What else should I write for my thing? In conclusion, the average water content found in the 3 samples is 23.21%. This shows the collected soil had high clay content percentage, which in turn holds more water. The calculations for the experiment for the content percentage for the water content I'm getting tired. For the water content percentage is simple and is simple and the experiments The calculation for the water content percentage is simple, and the experiment can be remade, or can be recreated. Can be recreated. Done. All right. I'll check it on. It's turned on Tuesday, so it's fine. Let's see. I have anything on desktop. I just put in earth science. Yeah, environmental science. Done, 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 done. Let's see what's in it. And then this. I guess I'll save it. Soil science. Oops. Let's see if it's actually in there, so I don't have to like. Where is earth science? Earth science, or environmental science? There is. Date modified. Okay, it's in there. Let's go. Alright. Alright, that's it for the stream.